Friends, good morning. Today's present of discussion is Coombs quinoline synthesis. Quinoline is an heterocyclic molecule. The basic system present in quinoline is naphthalene. Naphthalene is a fused ring system in which two benzene rings are fused. In naphthalene, if I replace the carbon at the first position by nitrogen, it gives quinoline. Coombs quinoline synthesis have been utilized to prepare 2,4 disubstituted quinolines. Coombs' approach was like this. Yes, cut the molecule like this. If I cut over here, this is one part and this is another part. This part can act as one synthon and this part I can act as another synthon. Here I have phenyl group and nitrogen. I can take a phenylamine and aniline as one of the starting materials. And here 1, 2, 3, a 3 carbon donor I'll take. I treat a 3 carbon donor with aniline, I'll get quinoline. Coombs reported this method of synthesis in the year 1888 for the first time. Here, the aniline condenses with a 3 carbon donor. I will take a dicarbonyl compound. So that this dicarbonyl compound reacts with aniline and cyclization occurs and gives rise to quinoline. Here, aniline condenses with beta diketones, that's a dicarbonyl compound, and I'll get in the presence of a strong acid, I'll get an intermediate Schiff's base which gets cyclized to give quinoline. I'll take aniline and treat with, if this R is CH3, then it is acetyl acetone. 1,3 dicarbonyl compound. The nitrogen in the amino group is in sp3 hybrid form, hence it has lone pair of electrons. The carbonyl carbon is electron deficient center, as adjacent to it there is an electron withdrawing group, that is oxygen. Unlike poles attract each other, this is electron rich and this is electron deficient. The lone pair of electrons are donated to the carbonyl carbon. Already it is tetravalent and another one more bond is formed, making it pentavalent and unstable. In order to maintain its stability, the pi electrons moves onto the oxygen and this gets converted into OH. In the presence of concentrated sulfuric acid, it increases the positivity of the carbonyl carbon. When I heat it strongly, I'll get a bond between the carbon and nitrogen. Then the pi electrons moves towards the carbon, generating a carbene ion. And here is the carbonyl carbon, an electron deficient center, and is an electron rich carbon. Unlike poles attract each other, they are near to each other. This excess electrons that's from the carbene ion attacks on the carbonyl carbon, and the pi electrons moves onto the oxygen to maintain the valency of the carbon, and the O minus combines with H plus, which is given by concentrated sulfuric acid, and cyclization occurs. Then the nitrogen and hydrogen bond breaks and these electrons are used to form the bond with the adjacent carbon. And once the bond is formed over here, the carbon become pentavalent and also unstable. To maintain its stability, OH gets kicked off. OH minus and H plus loses as water molecule. And here also the carbon hydrogen and bond breaks. The electrons moves and forms the bond with the adjacent carbon, and OH gets kicked off and loses as water molecule. Two water molecules are removed and aromatization occurs and gives rise to quinoline. This occurs for aromatization, and we know that aromatic compounds are more stable. This is the driving force for this dehydration. Quinoline containing drugs are many. Quinoline containing drugs finds its use as anti-malarial drugs, chloroquine, amisacrine, hydroxychloroquine, and whatnot. They find its their use as fungicides and quinoline antibiotics. They find their use as dyes and also flavoring agents. Let us look into its utility as drugs in the coming classes. Till then, have a nice day. Thank you.